I'm Paula from Energy Sparks. Energy Sparks is a charity that supports schools to reduce the negative impact they have on the planet by teaching school children about not wasting energy and by giving them the information and the activities they need to take action. We work with almost 250 schools around the UK, including 17 schools in Sheffield. We teach pupils how to analyse how much electricity and gas they're using in school, and we have almost 100 activities that help them to learn about their energy use and take action to reduce it. We all know that human activity is warming the planet and that even children can contribute to that. Because we're part of the problem, we can also be part of the solution. When we think about our own actions that are bad for the planet, we might think about driving cars, eating lots of meat, or leaving the lights on. Let's think a little bit more about that last one. How can something as small as leaving the light on be bad for the planet? To understand that, we need to understand a little bit about how our lights are powered. There are two main types of energy that we use in our homes, gas and electricity. Our lights and our appliances and equipment like TVs, fridges, game consoles, computers, washing machines and more are powered by electricity. But how is that electricity generated? Let's watch this cartoon and find out a bit more.
Energy 101 video explains the system used to generate electricity. And it also explains what it really takes to turn on a light bulb. In order to understand energy, we first need to start at the source, literally. Mother Nature provides the natural resource we use to generate power. From natural gas to coal, ocean tides to mountain winds, the energy we need to create electricity must first be mined, harnessed, or collected from the earth. Some of these resources are finite, including fossil fuels like coal and oil, but others are unlimited, like solar or wind power. But a lump of coal or a strong breeze alone won't create the power that turns on your light. For every energy source, a chemical or mechanical process is required to turn it into usable electricity. Every day, researchers work to find innovative ways to use our limited resources, process raw materials, harness renewables more efficiently, and find entirely new energy sources. Fuels like coal, natural gas, biomass, and uranium are used to heat water until it produces steam, which powers a turbine and generates electricity. That steam turns propeller-like blades around a rotor inside the turbine. This turning rotor connects to a main shaft which spins magnets with a coil inside a generator. It's the generator inside a turbine that converts mechanical energy into electric energy and creates electricity. Steam is an efficient method of producing electricity because the water can be recycled and reused as it changes back and forth between liquid and gaseous states.
So most electricity is generated using fossil fuels like burning coal, gas or oil. When they're burned, they emit carbon dioxide. More about that in a second. You can also generate electricity using renewable sources. Renewable meaning that, unlike coal and oil and gas, they won't run out. Instead of burning fuel, they use other methods to turn turbines or create electricity. I bet you can think of a few. Why not try and see how many of these renewables you can unscramble in 10 seconds? Go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Did you get them all? Because most of the electricity used in Britain comes from fossil fuels, although more and more of our electricity is coming from renewable sources, every time we use electricity in our homes, we're putting more carbon dioxide into our atmosphere. Now imagine this carbon dioxide gas is a big, cosy blanket. When heat energy from the sun hits planet Earth, this big carbon dioxide blanket traps the heat in our atmosphere. And the more carbon dioxide, the better this blanket is at trapping heat, so the warmer our planet gets. We know that this is because of us, because scientists have clever ways of measuring the temperature of the Earth and the amount of carbon dioxide in the atmosphere. They can look back hundreds of thousands of years and see that when we started burning fossil fuels and emitting more carbon dioxide, the temperature started to go up. Although we sometimes think it might be nice to have warmer weather in Britain, unfortunately we can't control where or how hot the planet gets. The climate of the whole world warms up, and while that means more dried out deserts in Africa and melting ice in the Arctic, in other places it means more rain. And yeah, that's right. We are going to get a lot more extreme heat here in Britain, but we're also probably going to get a lot more rain. So back to the lights. When we put on the lights, we're still mostly using fossil fuels, and that means every electrical item that we use puts more carbon dioxide into the atmosphere, and that means more heat is trapped in the atmosphere. Did you know that planet Earth is called a Goldilocks planet? Just like the Three Bears porridge, our planet isn't too hot, it's not too cold, it's just perfect. We don't want that to change, but we make the Earth's climate warmer and we're changing the planet quite dramatically. Can you think of some ways that's happening? These are just a few of the impacts of a warming climate on our planet. Everyone on Earth can play their part in bringing our carbon emissions down. With schools, we suggest pupils help teachers remember to turn equipment off by putting up reminders for them, and kids can also take responsibility for turning lights off when they're not needed. We make it easy for pupils to have conversations with their head teachers, caretakers, school cleaners and dinner staff about how they can all help reduce energy use. Let's have a look and see what the pupils at Saundersfoot Community Primary School in Wales have been doing to save energy.
Saundersfoot School would love you to meet our energy warriors, Saundersfoot Super Spark.
We would like to thank Jen and Janie for our fantastic online lesson and support. We are loving our energy project and we are sharing everything we do with the whole school.
Hi there, I'm Mr Nick Allen, the head teacher of Saundersfoot Primary School, and we've been working with Energy Sparks this term and Dosbarth Glass, our Blwyddyn Pedwar, and we've got some questions from our boys and girls in that class right now.
What is your opinion on our school's use of energy?
Okay, well, our school's use of energy, I think my knowledge has improved on that thanks to Energy Sparks and all you boys and girls in Blwyddyn Pedwar, Dosbarth Glass. We've understood a little bit more about our data, through the data of energy use, and we have a greater understanding of our spikes in energy, and we've done our best to reduce our energy use and our carbon footprint within school. But we're here in our boiler room for the upper part of the school. I'm learning lots about some of the facilities we have in school that I have not seen or been accessed before, me and my caretaker. So hopefully we'll begin to reduce and have a lasting impact on the environment here in Saundersfoot.
What would you like our class to do next to promote less energy usage in our school?
Okay, well, what I think we should do really is make sure the activities and strategies we have brought in are firmly embedded and adopted by every class across the school or the whole school. So in terms of last one, lights out, and turning heating down when we can. Although obviously in the COVID world that's difficult with our windows open. So I think we've really got to make sure what we do is deeply rooted and firmly embedded before we move on to the next. But however, I do think the next aspect we need to do is look at our gas use and when the heating comes on at certain times of the day, particularly over winter, and hopefully we can reduce our energy use by studying that. And with Energy Sparks, I'm sure they'll be able to help study the data on that and the impact we have on our gas and costs and the environment.
We have studied renewable energy. Thank you, Agni Co-op, for our solar panel.
Right, what are you, Trey? What's happening?
We're making renewable energy. Solar, wind and hydro are great sources of energy. We need to use them more. Thanks to Energy Sparks, we decided to start a whole school campaign to save energy and our planet. We did a tour the first, and then in language we wrote letters to our head teacher explaining what needs to happen. We had a day to try and use less electricity and gas as possible. Our school did a power down layer day on Friday the 12th of November. We did it on this day because COP26 was going to end. So we turned the heating off, we saved a lot of gas, and we did it to save the environment and to save the atmosphere. Turn your lights off when no one's in the room. Even if the light monitors are still not around, please turn your lights off, thank you. We turned the Chromebooks and their iPads off, so we saved a lot of energy.
So what happened in our school? Let's compare the data.
Energy Spark gave us this data on gas for our power down layer update. The orange line shows power down layer, our power down layer update. The yellow line shows the week before. Look how much energy we saved.
What happens at 10:30 a.m?
This is a poster we made together with lots of questions. These questions are from Mr. Anthony, our caretaker.
The peak at 2:30, the reason is probably in the pump house, which is the green square building at the back of your classroom. In there, there's a load of pipes which fill with water, and if we have a fire, the sprinkler system comes on and sprinkles water all over the school. And in that room, there's 2 wall-mounted electric heaters, and if the temperature gets below 5 degrees, they come on automatically to stop the water in the pipes freezing, because if the water in the pipes freezes, it'll expand and crack the pipes. So when it defrosts, it will all come out all over the floor, and the sprinkler system won't work because there'll be no water to sprinkle on any fire.
In our school, we are all energy warriors, and today I have a few suggestions to make our school more energy efficient.
Close the windows when the heating is on. We should adjust for timing with light sensors.
One day we could have a packed lunch day so the cooks don't need to turn the ovens off.
We have light monitors in every room. Don't forget to turn off your lights when you're outside. Next to Chromebook tells us the tins up the minute in use. I really hope our suggestions
Let's use our help.
Energy Spark challenged us to send a 26-word message to the Welsh Government. We even had our message retweeted by the Welsh Government.
So there's an awful lot you can do in school, but this isn't about taking action in school today. This is about what you can do at home. Did you know that over half of the electricity generated in the UK is wasted? Or that 40% of UK carbon dioxide emissions come from households? Did you know that 21% of your family's carbon dioxide emissions come from using electricity in the home? And the amount of carbon dioxide created by the energy that you use at home is about 3.2 tonnes every year. Well, what does that mean? You would need 53 trees, each growing for 10 years, to absorb that amount of carbon dioxide. So, are you ready to be an energy spy? Alright, Energy Spies, here's an Energy Spy activity to see what's using electricity in your house and how much you're using. You'll need to have a smart meter for this because you'll be looking at this display. You'll want to get an adult's permission for this activity and maybe even get them to join in. Grab the smart meter display and have a look at it. This is the one in my house, but the one in your house will probably look a little bit different. You press certain buttons on it and it will change the readings on the display. It shows different numbers and it shows how much electricity and gas I'm using at certain times. So it tells me how much I've used so far today, how much I've used so far this week, how much I've used so far this month, and this year. And it's a good idea to keep track of these figures because if you're on a budget or you're trying to reduce how much energy you're using, it's good to keep an eye on these. The display reading we want right now is usage now. This shows how much electricity and gas I'm using at this very minute. For this activity, we're going to focus on electricity use. Have a look at the display showing how much electricity is being used in your home right now. You might want to write that number down. 146 watts. W for watts. Watts is how we measure electricity. Now we're going to go around the house and switch on every single light, and then we'll check the display and see what the reading shows. Let's go! Look, it's gone up to 532 watts. Now the mathematicians among you might want to calculate the difference between 532 watts and our original 146. And it's not just lights. Your smart meter display can show you how much electricity other appliances use as well, like a kettle. See what happens when I turn the kettle on. So Energy Spies, here is your mission should you choose to accept it. Be smart meter savvy. You've seen how the display reading changes when you switch lights on and then off, and when we boil a kettle. Your smart meter display can show you how much electricity is being used right now. Can you see if you can get the reading down to zero? That's right. Can you get your electricity use down to zero? You will want to get an adult to join you on this task if you're switching things off. 1. Grab your smart meter. This has batteries so you can unplug it and take it with you on this task. 2. Walk around your house and turn off every single electrical item that you can at the wall. Even if something doesn't appear to be on, like a big TV, if there's a little light on it, then it's still using electricity. 3. Keep turning things off until you can get to zero. 4. Can't get to zero? Have another walk around and see what you haven't turned off. There will be something in your house that can't be turned off. Can you think what it might be? What's the closest you can get to zero? 5. Repeat this challenge every now and again to make sure that people in your house aren't leaving equipment on unnecessarily. Good job, Energy Spies! Okay, Energy Spy Challenge 2, Thermostat Ninja. This one involves heat. Most of us heat our homes with gas, a fossil fuel. In our homes, our boilers burn gas to make our water hot and our radiators warm. Many homes have a thermostat on the wall that can control how warm your house gets. The thermostat controls the heaters or the radiators in your room, but to make a room warmer or colder, you can change the dial on the radiator. What do you think the ideal temperature is for a UK home? The perfect room temperature for a UK house is in fact 18 degrees Celsius. Despite this, some people have their home thermostats turned up to 25 degrees C. That's like a summer day in Spain. Next question. How much of our home energy use do you think is used for heating our rooms in our homes? Over 60%. Now that's a lot of energy to be spending on heating our homes. And if we're heating our homes too warm, that's a lot of energy to be wasting. And that's a lot of planet-warming carbon dioxide to be emitting if it's not really needed. And it's not. We could turn down the heat by at least 1 degree Celsius in our homes, and many of us would not even notice a difference. However, each home that turned down its thermostat 1 mere degree could prevent 310 kilograms of carbon emissions a year. That's quite a lot of climate-warming gas that's prevented from being emitted. Can you believe that the UK would save a combined 1.18 million tonnes of carbon dioxide if every home turned down its heating 1 degree? Now, trees can absorb carbon dioxide from the atmosphere, but that amount of carbon dioxide would need 59 million trees growing for one whole year. And that amount of trees would take up almost 210 square miles of land, which is twice the size of Edinburgh and about the size of the Isle of Man. And not only is turning down your thermostats great for the planet, turning down your thermostat just 1 degree would save your household money, about 10% of your annual energy bill, which would be around £60 in the UK. So Energy Spies, here is your mission, should you choose to accept it. Turn down the heat. 1. Find an adult to help. 2. Get them to show you how to turn down the thermostat or turn down one of the room radiators 1 degree. 3. Turn down the heat. 4. See if anyone in your house notices the cooler temperature. Here's a spoiler, they probably won't. but you'll be reducing your heating bill and your carbon emissions and the amount of planet-warming gas going into our atmosphere. If you can complete these 2 challenges, then you'll be well on your way to becoming energy efficient at home. Don't forget that if you want to take action at school, you can head to the Energy Sparks website to find out more. We make it easy to understand your energy consumption, and with loads of activities to help reduce your carbon footprint, we're the perfect resource for tackling the climate emergency in your school. If you're not an Energy Sparks school, then find out more by emailing hello@energysparks.uk today. Otherwise, log on to your Energy Sparks dashboard and see what you can do today to take action. Bye for now.